Welcome to Faith and Science. I'm Dr. John Ashton. I think one of the main reasons that people reject the Bible these days is on the basis that radiometric dating has shown that the layers in the earth and the fossil layers are very old, millions of years old, in fact. The Cambrian, the bottom sort of layers where we start finding fossils are about, we're told, are around about 600 million years old. But this cannot be correct, and there's really good scientific evidence now that we can actually measure today why these dates can't be right. And this is very, very important because this whole concept that these layers, and particularly the fossil layers, are hundreds of millions of years old, underpins both the theory of evolution and this whole concept that the Bible account of creation, of a recent creation, can't be correct. And the reason is that these layers and rocks that we find in the continents above sea level cannot be billions of years old or millions of years, or hundreds of millions of years old, because they would have eroded away in much, 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 much shorter times. It was James Hutton, a Scottish physician who became a geologist, who suggested back in the late 1700s that the Earth was immensely old. Today, the geology schools and universities essentially take Hutton's views for granted, and we find again too that evolutionists accept that the continents formed about 2.5 billion years ago. In fact, some of the published ages for parts of Australia are more than 3 billion years, according to the dating. So, and at least 500 million years, 500 million years old. But again, if we actually look at what we can measure today, erosion rates, the continents can be nowhere near those ages. So water is the main culprit, that it dissolves many minerals, it loosens the rock and wears away the rock from the landscape, and it transports then these particles to the ocean. And so as the rivers are running too, they're carting this decomposed rock, this broken down material, away into the ocean. And also there is some wind erosion occurring. Glaciers moving down can move material as well, and of course ocean waves pounding on the coastline can erode it. But of course water does its eroding work as it falls as rain, and of course when it collects in these basins, and the basins empty out through the rivers, we can measure the volume of water discharged out of these basins, and the amount of sediments it carried that are suspended. And now it's difficult to exactly measure the total amount of material, because some of the sediment is being rolled along or pushed along the bottom of the river, and that's called the bed load. And it's not as easily observed and measured. And so often the amounts that are estimated coming out are probably going to be less than the actual amount that is carried out. Another thing is, if we have a catastrophic flood event or something that can transport a huge quantities of sediment in a short time, then this can also be missed. Nonetheless, sedimentologists have researched many of the world's rivers and calculated how fast land is disappearing. We can see that some rivers are actually excavating their basins by more than a metre in 1,000 years, or roughly a millimetre a year, which doesn't seem much. But when we add that up, if you accumulate it over a long period of time, it's quite significant. Others are right down to only 1 millimetre per 1,000 years. But since the average height reduction for all the continents in the world, though, as we look it over, is about 75 millimetres per 1,000 years. And if we, do the simple calculations, that if we say that the continents are, say, 2 billion years old, in 2 billion years, 150 kilometres of thickness would be eroded away. But yet the average height of the continents is only about 870 metres. There's quite a lot of data on this, ranging from about 830 to 870 as the average if you sort of levelled all the mountains and spread it all out, these calculations. And so we can see from these erosion rates that for North America, for example, the continent would be eroded away in less than 10 million years. At these, just at the average erosion rate. In fact, even taking the absolutely slowest rate of 1 millimetre, and 1 millimetre, is very, very tiny, less than the thickness of a match, per 1,000 years, and so it's a long period of time. Even the continents at 870 metres would completely erode away in 870 million years. And so, even at that rate, which is a ridiculously slow rate, 1 millimetre per 1,000 years, because we understand, a billion years is so long. So even at the slowest rate, most of the so-called geologic column that we observe with all the fossils would not exist because all those layers would have eroded away. The thing is, of course, that the actual erosion rate that we measured, averaged, is not 1 millimetre, but 75 millimetres, so 75 times that. So that's how we get the value in around 10 million years, the continents would erode away. So and we need to remember that all these layers have been dated by radiometric dating. And they give all these millions of years ages, and they can't possibly be correct, these ages. And there's other reasons too. If some of the material that we radiometrically date contains trapped carbon. When we carbon-14 date the carbon, we only get thousands of years or tens of thousands of years with the carbon-14 dating that are in the same environment that we're getting tens of millions of years, and maybe even more, hundreds of millions of years. In the case of coal, for example, we get hundreds of millions of years when we date some coal samples from the radiometric dating of the surrounding rock. And yet when we actually date the carbon-14 in these, we only get, tens of thousands of years. So we have these two independent avenues of evidence that show that these huge, millions and billions of years and hundreds of millions of years ages that we're being, inculcated with all the time, both in textbooks, signs, national parks, and documentary programs. Everybody wants to, it seems, jump on this bandwagon. This particular canyon is 70 million years old, and these particular petrified trees were, buried, all these long ages all the time. And these particular fossils are, 70 million years old, and these particular fossils are 130 million years old. All these sort of stories that we particularly continue being told just doesn't fit the evidence. We can see that also, of course, even looking at this 75 millimetre per year average erosion at the present state, there are areas that are eroding much faster than that. For example, in Papua New Guinea, erosion rates of 1 metre per 1,000 years are very common. Also in Mexico, in the Himalayas, and also in one area in Papua New Guinea, the erosion rate was measured at 19 metres per year. Studies done on the Yellow River in China show that a plateau as high as Everest could be flattened in 10 million years. So we can see that erosion is a major problem. The erosion is also a problem for the flatland surfaces that are considered very ancient. So why haven't these surfaces eroded? So we measure these very rapid erosion rates today. And in fact, actually, some of the other areas of erosion, if we look at the average lowering of land surfaces, the Ganges River, and these are data for erosion rates in millimetres per 1,000 years. In the Ganges, we've got 500 region of that river. We've got 560 millimetres per year, or nearly per 1,000 years, or nearly half a metre. If we look at the Alpine Rhine and the Rhone rivers in Europe, 340 millimetres. Now remember, doing the calculation, the average for the Earth, because of the dry regions, is 75 millimetres per year. But when we look at these alpine regions, it's 340. So, more than 4 times the rate. So, and we have similar regions in other parts. Even the Nile is 13 millimetres per year. So around all these different areas, the Yangtze River, 170 millimetres, the Tigris, 260, the Huang Ho River, 900 millimetres, and the Wei Ho River, 1,350 millimetres per 1,000 years. So we can see there's huge variation in erosion rates, and some areas would have eroded away very quickly. And so that's why the fact that we still find fossils, for example, on Mount Everest that haven't actually eroded away, that are dated as millions of years old, and yet the mountain, would have been seriously eroded away at that time, because we have these massive erosion rates in the Himalayas, as I mentioned earlier, in the order of a metre per 1,000 years. We can see that there's something terribly wrong with these really old erosion rates. Now, of course, geologists try to explain away this by saying that the mountains still exist because uplift is constantly replacing them. But if that's the case, the fossils should have all eroded away, and it would be, fresh uplift material there. Of course, another argument is that, the rates of erosion we were measuring today is because of increased human activity. Well, they've actually done studies on that as well. And the rates have increased only by an order of 2 to 2.5 times, whereas in order to fit in with that as a reasonable answer, the human effects would have to have increased the rate by several hundred times. So again, that doesn't work. Another suggestion has been, maybe the climate was being much drier in the past. But again, we know from the massive, lush vegetation in the fossil record and coal seams that it was actually a lot wetter in the past. Now, the other fascinating thing is that while people deny the Bible account and so forth, the Bible account of the global flood actually explains so many things. So the flood scenario is, of course, we had this massive amount of rain that collected in regions and then buried lots of things, and then mountain ranges were pushed up. And as these mountain ranges were pushed up, there was a massive runoff of water. And this massive runoff of water eroded the massive gullies, moved vast amounts of sediment, spread vast amounts of sediment over the remaining continents. And this mechanism very neatly explains, for example, the flat-topped mountains that we observe around. So you have these perfectly flat-top mountain ranges that are sticking up in different places, and towers like the Devil's Tower and the Steamboat Plateau in the US and so forth, where you've got this big lump of rock that's flat on top, but sticking out by itself. And what has happened, what's happened is the material around it has been eroded away, and it's left this material with the flat top. And these flat tops again show that the original material there was deposited down flat. A fascinating example that has been studied quite a bit is a rock formation called Devil's Tower in northeast Wyoming, which is an igneous remnant, so it's sort of like a volcanic plug that's come up that was once under the sedimentary rock. And so a lot of material has been eroded away. And so the flood mechanism also explains how these massive amounts of sediment were moved and spread very quickly. And these sediments that had contained the remnants or fossil remains of animals that had already been buried were then spread over large areas of land. And this also fits some of the work that has been done by paleontologists now as they look, for example, in the Morrison Formation. This is in the United States. This is a huge formation that spreads from New Mexico up to Canada and covers a vast area of the United States, and it's very rich in dinosaur remains. But occasionally they find a complete dinosaur, but mostly they find the dinosaur bones are sorted according to depth, so that you've got the smaller fragments are higher up and the larger fragments, larger bones are deep, which is exactly the type of sorting that we would expect as a large volume of water moving. The larger, heavier bones are going to move more slowly, be moved more slowly than the smaller bits. And also the recessive stages of the flood, which again creation geologists think probably started about halfway through the flood round, would have resulted in enormous erosion of vast areas of the continent. For example, this particular formation, the Devil's Tower, where you've got this igneous rock that came up, all the material, all the sedimentary material around has been eroded away. and washed away. And we can see where it has been spread. And there are vast amounts of erosion occurred very, very quickly. And they can see where hundreds of metres of erosion must have occurred very, very quickly. And one of the examples that we can look at, of course, is and how we can estimate this and how much erosion has occurred is looking at the rank of coal. So the formation of coal is mainly related to temperature, with the ranking of coal with the higher temperature. So we have from lignite to bituminous to anthracite coal. So the higher the temperature, you're going to have anthracite coal, lower the temperature lignite. And so temperature is proportional to the depth of burial of plants. And so the higher rank coal suggests deeper burial and thus greater erosion for the coal to subsequently be at the Earth's surface. So calculations have again been done that suggest that anthracite coal and so forth near the surface at one stage must have been buried under about 3,000 metres of overburden. And so all this had been eroded away. So we have these thicknesses of up to 1,000 metres of material being eroded very quickly. And the only explanation where you can have that occurring is again under the flood scenario. So you don't have a uniformitarian explanation for this. So again, this comprises further evidence that these ages are very, very young. A lot of studies have been done that are published in the geological literature that show that vast amounts of material had been eroded and must have been eroded very rapidly, and that's why these huge quantities of material have been carried over vast areas. If it was very slow erosion, it's not going to carry the material very far. It has to be rapid, catastrophic events. And that's why, remnants like steamboat rock, which is this big, long, flat plateau just sticking up on the plain. It's 275 metres high, almost vertically walled erosion remnant. And this would have occurred in a massive flood that occurred thousands of years ago that's called the Lake Missoula flood. But again, would have been part of the Noah's flood sort of recession effect. And so the evidence of rapid enormous erosion all over the Earth, because these erosional remnants are worldwide, is exactly what we would expect during the recessive stage of the Genesis global flood. So we have this powerful evidence that fits. Now, of course, when we're looking at these erosion rates that, again, show that rapid erosion has occurred in the past, some very interesting work has been published in this area, and perhaps it's hard to understand how can erosion do so much damage. Well, the reason is that how much, why so much erosion can occur during flood runoff. And erosion is related to what we call bed shear force, which is proportional to the fourth power of the velocity of the water. And so the fourth power, that means something raised to the fourth time. So, for example, if the velocity of the water doubles, the shear bed force increases by 16, right? Because 2 2s are 4, 2 4s are 8, and 2 8s are 16. And so if the velocity quadruples, the bed shear force increases by about 1,000 times. And so this explains why the amount of material that is carried away is huge. And it's very interesting that a very important paper was published in June 2017. And this paper, it was published in Nature Scientific Reports, so in one of the top journals. It's called Global Rainfall Erosivity Assessment Based on High Temporal Resolution of Rainfall Records. And so in this paper, the scientists looked at 3,625 measurement stations in 63 countries, and it's the first ever global rainfall erosivity database was used to develop the global erosivity map. And so you can look up the data there. And this was a study of the amount of energy that is impacted from falling rain and the amount of material that it can erode away. And again, if anyone's interested in that, as I said, it's published in Nature Scientific Reports, Volume 7, Article number 4175 in 2017, published June 23, 2017. So we have this powerful evidence that water can be extremely erosive. So we not only have that erosion rates show that the continents cannot be the hundreds of millions of years, thousands of millions of years old that radio dating measurements say that they are. So the radiometric dating measurements are obviously wrong. Also, the uniformitarian model that geology is based on cannot explain these massive flood remnants that we see all over the world, the massive spread of sediments under catastrophic conditions, but the Bible flood can. When we do carbon-14 dating, it again gives completely different results, much younger results, out by 1,000 of the ages compared to radiometric dating, and so it's a much more realistic dating. And again, when we look at structures like the Grand Canyon and so forth, we see these layers conformably on top of one another that are dated, thousands of millions of years apart with no erosion in between. So the whole model that is used to underpin geology doesn't fit the evidence. Instead, the biblical flood model does. We can trust the Bible. You've been listening to Faith and Science. If you want to re-listen to this program, just Google 3abnaustralia.org.au and click on the listen and radio buttons. I'm Dr. John Ashton. Have a great day.
You've been listening to a production of 3ABN Australia Radio.